a very eminent physicist called J.J. Thomson. Now, what did J.J. Thomson do? J.J. Thomson is the one who discovered the small particles called electrons. Now, how did he discover it? I'm going to take 5 minutes maybe to talk about it. Now, this is J.J. Thomson. At the Cavendish Laboratory at Cambridge University in England, Thomson was experimenting with electric current inside evacuated glass tube. Now, let me see if I can show you the kind of, here I have an evacuated glass tube. I hope you can see this. I'm going to keep it right in front of the camera. Now, this is a glass tube that is evacuated, and an electric current is allowed to pass from this end to here. In fact, this is vacuum. So, you connect this tube one end to the positive of a power supply and the other to the negative of the power supply. And what Thomson noticed was a glow inside, or electric discharge. Didn't we talk about electric discharge being the cause of production of light? Now, this is the experiment that Thomson did, and many discoveries were actually made from this electric discharge that Thomson started working with. So Thomson was experimenting with electric current inside evacuated glass tube. Now, this is the original glass tube he actually used. And if you look at this, electricity is connected to both ends of the tube. You know that electricity has a positive end and a negative end. If you look at your car battery, it has a positive end and a negative end. If you connect the two together, there will be a great explosion. Well, the positive is connected here and the negative is connected here. All right. Now, what Thomson noticed, can you see inside the tube a glow going from the negative end? Actually, the negative end is called the cathode and the positive end is called the anode. You don't need to worry about these names. So Thomson noticed a glow from the cathode to the anode. Well, you see, when a scientist notices something new, they want to discover more about it. What is it? Can we find out something more about it? Now, he discovered a mysterious radiation emanating from the negative end of the tube. That mysterious radiation that nobody has seen before is emanating from the negative end of the tube. So he spent a lot of time studying it. Now, he suggested that these mysterious rays are actually streams of particles. And he allowed these mysterious particles to fall on what he called fluorescent screens. And he noticed that when they fell on the screens, they produced flashes. Each time something falls, you see a flash. So he concluded that these streams of particles are very small and very light particles, much smaller than an atom. Particles that belong to the atom. So this is the first time anybody has come forward and suggested that atom is breakable. In fact, an atom is no longer the fundamental building block of materials, but atom is made up of constituent particles. So Thomson suggested that this glow or this radiation is actually small particles. And where are these small particles coming from? He said these small particles are coming from the atoms that make up the cathode, the negative electrode of that tube. All right. Well, now how do a scientific idea get respectability? When other people perform the same experiment and observe the same result. Now Thomson called these particles corpuscles and suggested that they might be the constituents of atoms. Well, he didn't put forward any theory. He suggested that these may be particles that make up the atoms, the small particles of the matter. Now, later experiments showed that, well, when I tried to summarize this one sentence, this is the work of several years by J.J. Thomson and his collaborators. So later experiments showed that these are negatively charged particles. In fact, these particles carry a negative electric charge, and these particles were subsequently called electrons. And it was observed that they are indeed part of the constitution of all matter. You know how Thomson arrived at that conclusion? He used many substances as the negative electrode, and he observed that all these substances resulted in this same radiation. So what is the conclusion? The conclusion is that these minute particles, which are now called electrons, make up the constitution of all matter. That means if an atom is the basic part of all substances, then this atom contains these electrons. So atom is no longer the basic constituent. An atom can be broken into smaller pieces. Now, studies by an American physicist, Robert Millikan. Now, Millikan did a lot of studies on these mysterious rays. Now, he measured the mass, he measured the electric charge. You see, a lot of experiments was conducted by Millikan. Now, he measured the charge of these electrons, and he found that they carry an electric charge of 1.6 times 10 to the negative coulomb. And each of these particles has a mass of 9.11 times 10 to the negative 31 kilogram. How small is it? It's a very, very, very small mass. You can't even imagine such. It's a trillionth of a trillionth of a trillionth kilogram. So small. All right. Now here comes J.J. Thomson with a model of the atom. So J.J. Thomson said, okay, let's make a picture of the atom. What is an atom? Which is the smallest part of a substance. So, let's see what J.J. Thomson said. One of the first atomic models was that proposed by J.J. Thomson after he discovered the electrons as a result of his work with the mysterious rays. In fact, those mysterious rays were called cathode rays. You know why they were called cathode rays? Because these were radiations coming from the cathode going towards the anode. Well, since each atom was electrically neutral, well, you see, an atom as a whole does not carry an electric charge. Well, that means if an atom has to contain a negatively charged electron, then that atom must also contain some positive charge. Then only an atom can be electrically neutral. All atoms have to be electrically neutral because you are electrically neutral, I am electrically neutral. My aluminum rod, you are now familiar with this very much. You have been seeing this for how many days now? This is electrically neutral. My remote control is electrically neutral. That means the atoms with which all these are made of are electrically neutral. What does that mean? it must contain equal amounts of negative and positive charges. Only equal amounts of negative and positive charges will make a substance neutral. So, since each atom was electrically neutral, Thomson thought that it consisted of a relatively large, uniformly distributed positive mass. So this is the picture of the atom Thomson proposed. He said an atom is a relatively large, positively charged mass, and these electrons are sort of distributed inside this mass. A beautiful picture. Look at the Thomson's picture of the atom. He said the atom is a body, is a positively charged body, and inside that atom these negatively charged electrons are embedded. And you know what the model of the atom was called? It was called the plum pudding model of the atom. In other words, the model he proposed was like a pudding. The pudding is the atom, the positively charged atom, and the plums are the negatively charged electrons, so that the atom as a whole is electrically neutral. Now, Thomson's careful experiments and adventurous hypotheses were followed by crucial experimental and theoretical work by many others in the United States, Germany, France, and elsewhere. Now remember, a scientific discovery does not become a theory or a law until it has been experimented and results, consistent results, has been observed by people working on the subject all over the world. Then only a scientific principle will receive respectability. So people from all over the world worked on this, and we will now look at the result. And that is the story of this lesson. Now, these physicists opened us a new perspective, a view from inside the atom. So our story actually unveils into looking into the atom, a view from inside the atom. And it is J.J. Thomson who started that. So this is the first picture of the atom that anybody ever knew.